just a few more minutes as we let folks come in. All right, it looks like we can go ahead and get started. Hello again, my name is Kara Sobers and I'm the Media Digitization Manager at the Smithsonian Institution Archives, part of the Smithsonian Libraries and Archives, where we collect, preserve, and share the history of the Smithsonian Institution. On behalf of the Archives, it is my pleasure to welcome you to today's program and the 10th installment in the Smithsonian 175th Film Fest, Films from the Smithsonian Institution Archives. Before we get started, I want to gratefully acknowledge the Piscataway people on whose ancestral homelands I live, as well as the diverse and vibrant Native communities who make their home here. I encourage everyone to learn more about the historic and current Native communities in the area that you call home through your local museums and centers, as well as the Smithsonian's National Museum of the American Indian. And now for a few details about how this will all work. The chat box is where we'll be communicating with you throughout the program and where we'll post links as they come up in the discussion. If you are having technical problems, please send a private chat to either myself, Kira Sobers, or Emily Neckrish, my co-coordinator today, and we will try to help you out. If you have any questions throughout the program, we encourage you to put them in the Q&A box and we will answer them towards the end. We hope to see you next month for the 11th installment in our Film Fest on June 23rd from 12 to 1 p.m. It will feature SLA conservator Nora Lokshin and conservators from the Hirshhorn Museum and Sculpture Garden and the Smithsonian American Art Museum discussing outdoor sculpture conservation techniques. For today's presentation, we will be screening a 1982 episode from the series here at the Smithsonian called What Lives in Your Lawn, followed by raw footage from the 1995 Bug Fest, an interactive event to teach children about insects, arachnids, and myriapods, held by the Smithsonian's National Museum of Natural History. Because the Bug Fest film is camera raw footage, there's a good deal of crowd noise that can sometimes make the curator commentary hard to hear. After the screenings, SLA's preservation coordinator, Allison Ruppert-Gerber, will join us for a presentation about pest management at the archives before taking questions from the audience. Allison Ruppert-Gerber, she, her, is the preservation coordinator for the Smithsonian Libraries and Archives, where she oversees the preservation program for archival collections. Since joining the archives in 2015, Allison has served in multiple leadership roles to move forward preservation initiatives within the institution, including leading a project to assess and rehouse oversized paper collections, conducting a comprehensive assessment for pan-institutional audiovisual collections, and most recently, spearheading efforts to survey nitrate film collections across the Smithsonian. She received her Master's of Arts in Museum Studies from Johns Hopkins Universities and a BA in Art, History, and Chemistry from Seton Hill University. And now I'll turn it over to you, Allison.
Thanks, Kira, for the intro. I just wanted to welcome everybody today. I hope you enjoyed both of the clips. You're going to be seeing a lot of fun things with bugs, but we're going to then talk about what to do when you find them in your collections. I hope everybody was able to eat lunch before, or maybe wait until after seeing the films to go ahead and eat your lunch. But anyway, please enjoy the films and we will chat in a few. Thank you.
No, it's not a newfangled lawnmower. It's a vacuum cleaner. Brian and Jeffrey Gottlieb and their mother Grace are performing an experiment, trying to find out what lives in their lawn. Using a stocking instead of a vacuum bag, they've sampled the population, emptied it into a plastic bag, and are now giving it careful study.
See, look at him, Mom.
Let me see.
Can I see him? Here's a bee. That's a bee, yeah. No way.
The experiment, part of the Smithsonian Family Learning Project, grew out of 10 years of research on lawns by Dr. John Falk, Associate Director for Education at the Smithsonian's Chesapeake Bay Center for Environmental Studies. As an ecologist, he thinks most people have the wrong idea about lawns. They're not just grass at all, but complex ecosystems with hundreds of different inhabitants.
It would be like looking at a tropical rainforest from 5 miles up in an airplane. If you were the same size as most of the insects living in this lawn, namely about 1 millimeter, and you get down in here, that's a very tall and a very rich system as well.
Lawn populations, from the plant species to the insects and birds that feed on them, are just about the same throughout the U.S., and they've learned to adapt to that major predator, the lawnmower.
Basically, insects that live in lawns are able to avoid getting decapitated by a lawnmower. And those insects that are not very good at that ultimately don't survive in a lawn.
Vacuuming the lawn is one of about 50 activities in the Smithsonian Family Learning Project, designed for families to do together. This one, when the grass is dry, the activities focus on the home, stressing that science can be found in simple things. For Brian Gottlieb, it looks like vacuuming the lawn worked.
I think that we're walking on lots of insects instead of just lots of grass.
For more information about the Smithsonian Family Learning Project, you can write to John Falk at the Smithsonian in Washington, D.C. Here in suburbia, not far from the Smithsonian, I'm Ann Carroll.
Over inside the bag. Okay. Stick it down and shake.
We're here at the Smithsonian National Museum of Natural History. This is the first annual Bug Fest.
Well, we're showing people that eating insects is something that's quite reasonable, and they actually taste good. The scenario is everybody eats lobster and crab and various other arthropods. Why not eat insects? And so what we're doing is giving a couple of different ways that you can eat insects. There are lots of different ways, but we've got just a couple of different ways here for them. Certainly full of a lot of protein, but I really don't have a figure on that. Okay. They have done nutritional studies on them because there are lots of places where they eat insects all the time. Africa, for example, is a place where there's not a whole lot of protein. I mean, protein is a very difficult commodity to get a hold of. So insects are a wonderful source of protein there.
Mixing up a cheese dip, and we're going to have cricket nachos. We're going to have tortilla chips and then cheese topping and then fried crickets on top of it. And they're really quite delicious. That young man there is going to be just anxious to have some.
Have a mealworm cookie.
What young man? He disappeared.
We first fixed these at the Insect Expo at the Entomological Society of America meeting in Dallas last December.
Yummy.
And we had about 3,000 grade school children come through. And it was amazing. We had more children and teachers eating cricket nachos than we did entomologists.
Those were good guys. Those are the young tender ones. Those are the kind I like.
These are good ones, I'll tell you. These are some of the best crickets I've ever cooked.
Look, the cook's always first.
Oh, here, I'll show you.
This is Carl. You want to try Julia?
I'll have
bodies.
one
You'll get a single, you'll get a double.
I'm going to get a single.
Okay.
They're little
That's a big. Let me get a burnt one.
They're pretty well done. Trust me. It's good. Crickets really taste. Cricket tastes much better than the mealworm.
Try it if you try.
Throw crickets
I'm not gonna eat the worm, but just the worms.
Here, aren't I? Okay, let me show you. See, here's a cricket. This is a good one. This is a female. See, here's a cricket. Everybody see it? Tastes like a nut. Very good.
It's a nacho chip.
Is it good?
Is it good?
Look up and tell the lady what it's like.
He's too busy eating it, huh?
What does it taste like?
Tastes like butter.
Like butter.
I want to see y'all eat. Oh no, no thanks. Those are crickets. Yeah, that's smart.
He likes the stuff.
Maybe you look sick.
You don't like them?
You don't like worms? You don't have to eat it. You want to try anything else though? You want to try a chip without a cricket on it?
It's not true. I bet you've never had one.
What is that?
That's all that good. Pick one out. Would you like that? Yeah, you want to go ahead.
Stick it in your hand.
Can I do it?
There you go. You take one right out. But eat it like this.
You do it.
Let's see what else we have.
Eat it like this. Yeah, that's
It's pretty good.
Isn't that
just get out. Can I eat it?
coming through?
It tastes kind of like sunflower seeds.
I have to ask, where do you get them?
He's from?
You know, I don't know where actually those are from. We'll ask Patricia in a minute. She knows a little bit behind those histories.
300 million years old.
How old are they? They can, in captivity, I've had them living a year and a half. My feeling is that then the Amazon probably also until somebody finds it. They eat plant material, leaves, flowers, sometimes
Are you saying cicada or cicada? That's quite different. Yeah, that's.
What do you think you feed them, Austin?
And it has clear wings.
Portable cricket cages for the pocket. How novel. Made in China. More good luck. That's sort of an apartment style. This is for the royalty.
Kind of intermittent.
Grown the wasp caterpillars been in. Yes, they pop out, they spin their cocoons.
This happens with the speckle.
Yeah, you see pictures of their smooth bodies with all these. It kills them. And it's actually a good idea to save the wasps if you ever do get them, because then we can get a record of what was feeding on the caterpillar. Who knows, it may be new information.
Right. And they pop out fast too.
Yeah.
So it didn't take us
You look at it.
The emergence of the wasps, I think, is not till the next cycle, next spring. That's a smooth caterpillar like this one right here. You got any questions about caterpillars? I didn't know what you're looking at. I think it's neat.
or you know what they are.
I'm doing go around and collect. That's how we learn how to collect. Before I started doing any collecting, I started collecting bugs. Actually, when I went in the net, I started collecting.
sit on one by mistake. They have this very fine hair all over the body.
They fly?
Solitary, they're not in colony.
Is this again in the west? Or?
These, I think, are from South Carolina. Whose relatives are being started from that pattern to copy the monarch.
Yeah.
And in Florida, in the southeastern U.S., you've got the queen, which is a relative of the monarch. It's also distasteful because it too feeds on milkweeds as a caterpillar. And the viceroy, when it gets down into Florida, gets this color because this is much more common than the monarch down there, and so it's more beneficial to copy that. And this
You say distasteful. Who eats
butterflies, birds, and sometimes lizards. That. This is in the same genus with the viceroy, and it again has departed from this pattern to look like that. This is the female of this species. Only the female is common. This is our common tiger swallowtail, and around here about 40% of the females of the tiger swallowtail look like this, and again they're mimicking that. The others look like the male except for an extra amount of blue. Of evolution behind this, from many millions of years. Yeah, many generations.
These are moths or butterflies?
These are butterflies.
But is it
moths here.
Yeah.
Why big butterflies and big moths?
Wow, you got 4 stamps.
It's just the way they've evolved. These things as caterpillars make mines in leaves. So instead of
Why don't you have lunch with Doug Miller? I bet they'd love to. One could.
See, Vishai came down and printed that out on our colors.
That little tiny speck of a wasp. Yeah.
It's gigantic. Look at them. They're all beetles. Is this a real one right there, though? No. That's jewelry. That's pretend.
Kind of scary.
Not yet. I go in the collection.
Found the silver, but these are all
A friend of mine, I think is cat. I saw no sign
They
of
feed
life.
on the lawn. When did that? Dark and oils and dark.
Do they fly?
Yes.
As I would hear, is only in the, like, if I was up at, walk through the room at 3 o'clock in the morning, everyone's okay.
Oh, I see. Yeah, they do fly, and they don't fly very well. There's the disadvantage beetles have is they have 4 wings, but only 2, the hind wings, which are the flying wings, and the front cover wings though are like shields. In fact, the scientific name for beetle, coleoptera, means shield wing. And probably that's why beetles are more successful than any other insects, because they have these shields protecting their flight wings and their innards. Wouldn't want to be riding on. Some woman just came by and said she doesn't like beetles anymore. Riding a motorcycle.
They tell you what it was?
I've heard that.
You wouldn't want to be riding a motorcycle.
Okay, great.
They fly.
They
The
turn it
jeweled
into a
bug.
piece of,
You turn it into a piece of jewelry.
A little bit of everything.
But they keep it live, and they walk around with these live beetles on them.
oh yeah?
Somewhere in Central America.
That's it. Very simple. Well, 1 out of 4.
Because some of these slides we have in the collection 100 years ago. Yeah. I know that's good. Well, it's fine. So we try to divide it up like that.
This is what she was drawing.
Actually, this right, that's correct. And actually, I have this is not only finished, but it's
Very good.
so that they can
First
see
timer?
the final.
This
So I'm
is
trying
the
to get
adult
them to
sawfly.
Trying to get them to understand.
simple, but it's a lot of work.
Suppose they would have it.
What I have is
Yes, yes it is.
He was painting something that looks like that. Look at them. That's great.
That yellow can be kind of weird sometimes. I can't believe how expensive everything is. Yeah, they are. That used to be $10,000.
This is what he's drawing.
That anymore. Now, this is how it works. When you're, this is the candlelis. You're seeing your specimen. Where's that? You're seeing your specimen with 2 eyes. Here, sweetie, I think they're doing something. And then, that's good. When you pull this out of it, reflects the mirror, and the mirror reflects the paper. So that's exactly. So it's here's where it doesn't go through this. There's the image. You see, you opened up. You close this, then you put a closet, a door in front of this glass. When you open it up, you open the door, and then the little piece of glass and mirrors in there can see this mirror.
Oh, okay.
See, there's a hole here. If you look over here, you'll see there's a hole. After we do this, that means this
Here's one. But I knew it was a scorpion.
Good.
There's another painting.
We can have an artist rendition here. Glittery red, fire red, fire red and spray in here.
Yeah, that's why I got you. Play right in.
Yeah.
Come back. Superb. Here, I'll take it. Are you doing anything else tonight?
Sorting specimens from the field. Now, why don't you use 100% alcohol, or are you just making it go?
It's extremely difficult to get and very expensive. So we use lower concentrations that are adequate to do the job, but that are more economical.
It also hardens the specimens more, doesn't it?
Oh, very true. It certainly does. It makes them very brittle.
They're pliable. That's why I always call them little mushies.
Right.
Okay.
All because they do not make the specimens as brittle as isopropyl does.
Oh.
Isopropyl makes them even more brittle than ethanol.
Oh, yes.
Ethanol is best.
Hi there, everybody. I hope you enjoyed those clips as much as I did. I love watching the kids mostly attempt to eat the bugs. Can't say I've ever tried that myself, but I love that the kids try to do it. So moving on to talking about what lives in our collections. So you've just had the chance to see how fun bugs can be, and even as meals. But I wanted to talk about some situations where they may not be so fun. And so here are two images of Smithsonian spaces. One of our Hauptgarten, and then one is of our archives collection space. And so love to see bugs in the garden, not so much in our collection spaces. So the term used for holistic management of small intruders in our collections is called integrated pest management. And so I highlighted 4 key things to IPM that I think explain it in the best way. So prevention, monitoring, identification, and treatment. So this is the general order you'd like things to happen. We would like to always prevent infestations from happening. But again, this is a cycle. And so you may have to come back around and skip steps. So here are a few common pests that we find in libraries and archives specifically. If your collection consists of other materials, you may find different pests within your space. Also, this is by no means an exhaustive list. This just gives you a good sense of what we might come across in our collection. So each one of these insects is attracted to different food sources and prefer different environments. But in general, they typically like warmer temperatures and humid environments, don't we all? So for us in the archives, our most common invaders tend to be silverfish and book louse, or book lice as the multiple, with the occasional cockroach in there as well. And especially if we forget to put water down our floor drains. And to expand on that a bit, so cockroaches love to crawl through pipes and invade spaces. And we deal with that most often in our conservation lab and in our bathrooms. But fortunately, there are some simple ways that you can thwart the cockroach's journey. So first, we have installed tightly woven mesh under our floor drains. And then we regularly pour water down those drains. Weekly, I think, is probably ideal for that, to make sure that the water within the P-trap is replenished. So this can dry out after time if you're not using those drains. And then the insects like to crawl up and out the drain. So just a little side tip for you all: if you deal with cockroaches, that's the best way to prevent them. So what makes our collection so attractive to bugs? So the environment can play a big part in providing a comfortable, homey space for bugs. So like I said, many pests like increased temperatures and high humidity. High relative humidity also creates an environment where mold can really take off, and a lot of bugs love to eat mold and fungus. Dirt and dust can also contribute to making a homey environment for insects. They love to munch on the different fibers and other insect particles found in dust. And I will warn you, I did warn you to eat your lunch before this presentation. But ultimately, our collections themselves serve as the primary attractant for pests. So I've made this table here just to clearly lay out for you all, like, what some of the common food sources we come across, and then what insects will be attracted to those. This is really important for us. It helps us to better identify our risks, and also helps us to develop plans for prevention and treatment. So you can see here, like I said previously, mold and fungus is most attractive to book lice. I feel like everybody thinks that book lice, they love to eat the books, which is very true, but they are actually trying to get to the microscopic mold and fungus that lives within the books. Starches, such as adhesives that we use even in conservation, dried seeds and grains, can really attract those silverfish and fire brats, and also cockroaches. Animal fibers or skins. So for us, that means carpets, sometimes fur within our collections, but wool, silk, parchment, and vellum can all attract the varied carpet beetles. And then plant fibers, such as herbarium specimens, cordage, or our paper, are particularly attracted to cigarette beetles. And then I just put at the end there, almost anything. As we all know, cockroaches will pretty much eat anything. And so unfortunately, we can't really identify a primary food source, although I have read that they love fermented foods. So let's try not to keep those in collections. Okay, so like I said previously, prevention is preferred, of course. It can help us from having an infestation happen. And so there are plenty of things we can do to support prevention. And the first thing is good housekeeping. So we want to make sure our spaces are clean. We do regular dusting, regular vacuuming, regular sweeping of our spaces, any space that collections are being stored in. Environmental controls are really important. We want to keep the temperature low and the humidity low, so that space is much less attractive to insects. Assessment and quarantine. So we want to regularly look at our collections. Are we noticing any sort of issue, which I will have images for you all later? And then are we quarantining those collections that we know might have some issues so that they don't spread to other collections on the shelf? And then of course, can't ever forget training. So we want to make sure that staff who are actually looking at collections are trained to notice where there are issues and if they notice damage that could be contributed to pests. And I have a nice little arrow here. This all should be put into standard policies and procedures that are followed and have a regular timeline for some of these, particularly the good housekeeping I'm thinking of. So what traps are right for you? So there are a couple of considerations to make as you start thinking about what traps you want to put in your spaces. So I have some considerations listed here. So what's the frequency of use? And what I mean by that is what is the frequency of use in your space? Is it a really high traffic area? Is it somewhere where you know that you've had pest issues before? Temperature. So if something is really low temperature, really high temperature, that might affect what type of trap you use. And then the type of insect. Specific insects are more attracted to traps than others. And so this image here, which I love, is a blunder trap. And so this is more suitable for pests that crawl on the ground. But if you have flying insects, you're going to want to think about hanging traps. Because most certainly a flying insect would not fly directly into a trap on the ground. So there are also different mechanisms for traps. So like I said previously, we have our blunder traps, and I love that name. But what it basically means is that you place it on the ground in the path of insects and just hope that they crawl across it. These don't contain any sort of lures or pheromones in them. But that upper right one there with the green lid, so that's a pheromone trap, and you can actually put specific chemicals in it that will attract the bugs into it. The funnel traps are great. I just recently learned about these. They also can have pheromone lures in there, but they also work on like a funnel system where the bugs will come into the top and they'll have different grooves that will actually encourage the bugs to go down into the cup, and then they get trapped in the cup. I think we're also all very familiar with electric traps. We see these most often outside. I actually have one outside in my yard that I use for hoping to get rid of mosquitoes during the summer. But these will actually attract insects with the light. And then once they get close enough, it will electrocute them essentially. And then the good old faithful snap traps. And these are obviously most common used with rodents. And we, at the archives, we do not deploy snap traps because we thankfully have not had issues with rodents in our building. Okay, so you've caught something. How do you identify it? So one of the easiest things to do is to use magnification. Sometimes these bugs are really small and it's hard to identify them without any sort of help. And so you don't need a high-powered microscope. There are some very affordable options available that can give you 60, 80, 100 times magnification. It makes it really easy to help identify your pests. There are a ton of great resources out there, primarily, and I will mention this one multiple times throughout the presentation, museumpest.net is a great group of folks that have put together a ton of resources, including images, pest fact sheets that really help you to identify those pests. And then the National Park Service also has their conservograms. They have a few about IPM. And last but not least, you can always phone your friendly neighborhood entomologist. And now we're lucky here at the Smithsonian that we have entomologists on staff that we can call up regularly, but there are also entomologists out in the field that you can call to help you identify your pests. So I want to highlight this, tracking your findings. It's incredibly important in any monitoring situation that you detail what you actually find. You want to include dates, locations, your trap names. It's really helpful if you name your traps, and then identified pests. And this is an example here of what we use at the archives. This is just an Excel spreadsheet, but it has each one of our locations where we have an IPM monitor launched. And so the spreadsheet allows for data manipulation, so you can actually spot trends or areas of concern. So if you're having some frequent flyers in certain areas, you can start to track that and see if you need to maybe implement something new to help reduce pests in that area. And then I also said here, you want to make sure you keep it in an accessible location for staff. It's great for all of your staff to know where there are some issues. It increases communication, doesn't really need to be locked down. So just make sure that all your staff know where your problem areas are. More eyes on it, the better. So damage to collections. So all of these pests should look very familiar. They were highlighted on a previous slide, but what does it actually look like when they cause damage to our collections? So each one of these looks a little bit different, and the actual damage can help you identify what pest it is. And so you'll see here that each one does look a little bit different. The book louse here has sort of penetrated through the pages. The silverfish on this one page has created this really great pattern on this sheet of paper. And then the cigarette beetle all the way on the end has sort of created these little pads through the cover of this book. And then of course the carpet beetle there in that rug, you can see the damage that has been caused there. So you found the bug, you've seen the damage, now what do you do? So before considering treatment, you'll want to just think about a couple of things. So what type of material is affected? Is it primarily books? Is it paper or manuscripts, photographs, or AV materials? All of them, it's really important knowing what the material is because it will absolutely affect what sort of treatment you use for these. What is the scope of the infestation? So do you just have one object that's been affected? Is it a record storage box, or is it an entire cabinet within your collection storage or an entire shelf that has been infected by bugs? What resources are available to you within your organization? This is really important to know what is at your fingertips to use in case you need to take care of something in a timely manner. So do you have a walk-in freezer? Do you have a chest freezer? Fortunately at the Smithsonian, we have a CO2 bubble that we could use, and that's probably not very commonly found at a lot of organizations, but if you have these resources available internally, you should absolutely utilize them. And then are there funds available to support the use of vendor services if you need to send things out to a specialized vendor? And I just wanted to highlight a couple of most common treatment options. Again, this list is not exhaustive. There are a lot of different things that you can do, but I wanted to highlight these specific things. So one of the most common treatment options that people use is freezing. But actually is not the most effective if it's not employed properly. So it basically is just using low temperatures to kill insects and eggs. A lot of people use this method for prevention. So you have collections coming in, pop them in the freezer for an extended period of time. And it just sort of acts as a preventive measure to make sure that even if there was something microscopic in there that you couldn't see, that it ends up killing it and doesn't turn into a bigger issue. The issue with this is that, so the preferable specs for freezing is -20 degrees Fahrenheit for 72 hours. A lot of times, depending on what freezer you use, it's really difficult to achieve -20 degrees Fahrenheit. I think that's about 29 degrees Celsius, -29 Celsius. And so what we do, because our freezer does not go that low, we just put it in for longer. It can be in there up to weeks for us to freeze our collections, which is okay. The only issue with that is that sometimes insects can go dormant. So even if you leave it in a higher frozen temperature for a long period of time, some insects can just sort of go into this dormant phase. And then as soon as you warm them back up and go to vacuum off the collections, could sort of come back to life in a way. So you just have to be really careful when you're using freezing, that you're using it properly. I also made sure to include this column here for do not use these methods for. So freezing really isn't appropriate for everything. And I just highlighted a few collection objects here that really shouldn't be put through freezing. Again, this isn't everything, but this is sort of what you find in libraries and archives collections that shouldn't go through the freezing process. So next thing on the list is a controlled atmosphere treatment, or CAT. And I just highlighted a CO2 chamber. There are a couple of different methods with CAT, but CO2 is probably the most common. And it's basically creating a controlled atmosphere. You use carbon dioxide to displace all of the oxygen within a space. And it basically suffocates the insects. And so I just included the specs for that there, what is ideal for a 4-week treatment period. The only thing that's been identified, maybe not appropriate to go through this, is certain foams. It's been noted that some distortion happens, but it's been contributed to pressure changes for that, not actually the CO2. Next on the list, oxygen scavengers. So these are really more appropriate for smaller treatment. So if you just have one book or one item that really needs to be treated, you can use an impermeable enclosure, custom made one that you can modify the atmosphere within that enclosure. And so you're trying to get it to be mostly nitrogen. So the oxygen scavengers react with the oxygen and pull it out of that atmosphere. And again, sort of works on the suffocation mechanism for insects. The specs for that is very, very low oxygen for 21 days. And the primary things that you wouldn't want to do that with are Prussian blue dyes and pigments. And now these last 3 things here, not necessarily treatments, but should definitely be employed in your IPM. Isolation. So if you're not quite sure what to do or what treatment method you want to employ, isolate those collections. You can put them into bags and you can use the quarantine method until you can sort of figure out what you want to do with them. This prevents the issue from getting bigger. And so definitely something that should be used. Vacuuming. So after you have treated collections, it's incredibly important to vacuum them. You remove the carcasses, eggs, and any frass that might be present that will prevent a future infestation. And then lastly, rehousing or removal of unnecessary materials. So placing collections into new enclosures, you're just getting rid of that unnecessary thing that might be harboring eggs, frass, old carcasses, and putting it in a new enclosure. You also want to think about removing any packing materials that maybe don't carry any value. Of course, I put in parentheses here as determined by staff, because some things might seem like they don't have value, but you may want to keep. But I'm thinking of tissue, photo sleeves, any sort of interleaving that could be disposable. Just go ahead and get rid of that because they may harbor eggs and frass. Okay, and I wanted to highlight some of the primary resources to use for IPM. I want to give another big shout out to museumpest.net. It is a great resource. I pulled a lot of images from there for this presentation and a lot of information from there. So be sure to check that out. We also have the National Pest Management Association Resource Center, National Park Service conservograms, and then our colleagues up at the Canadian Conservation Institute have also written some notes on IPM. And with that, I'm going to let the discussion begin.
Thank you so much, Allison. Bugs gave me the heebie-jeebies, so I appreciate you doing the hard work for us to keep our collections nice and safe so that I don't encounter any of them while going through materials. We've had a couple of questions come in. One to start with, you mentioned that staff should be trained in pest management. What type of training would you recommend, especially for smaller archives or libraries where staff are wearing multiple hats?
Yeah, I think that the best training to start with is probably identification. Because I think, not that it's the simplest thing to do, because there are a lot of type of bugs, but we can narrow that list down based on what we most commonly find within collections. And so I think that training up your staff so that they can at least positively identify what pests you're finding in collections is most important. A lot of these treatment options that I highlighted, you can send out to vendors who specialize in this. So I don't want people to get bogged down in trying to figure out how they want to treat this. If you can identify it, and if you can see if you're having a consistent issue with a certain location, I think that is the best thing to do for a small staff. And then you can call on those experts if you really need to move into the treatment option.
Thank you. The next question is, does the archives have a standard protocol for inspecting, cleaning, or fumigating incoming collections?
So we do have some standard protocols for freezing, which I mentioned we do have a freezer on site. We also, we do preventively freeze certain collections that come to the archives from certain offices that we know are just in locations that are more prone to having pest issues. And so we do some prevention on that end. Every collection gets assessed and inspected when it comes in by our archivists. They're very well trained on spotting issues. So if something pops up, they come to the preservation team and we come up with a method for treating that. So yes, we have very, very well run workflows here for treating pests when they come in.
So that they're teaching museum studies course this summer and their students enjoyed and learned a lot from the presentation. They said their best pest control story is when a live scorpion hitched a ride on a masquerade costume. That was quite an adventure. I'm glad that we don't have live scorpions.
I was just going to say that I am thrilled that scorpions are not something that we come across on the East Coast.
Okay, so next question. If there's an infestation in my personal archives, what immediate steps should I take to prevent further damage?
Yeah, so I think one of the, I say it's the easiest thing, but sometimes it's difficult, is to get things into better environmental conditions. I'm guilty of it as well, but I think in our personal homes, we're always so tempted to just put all of the things that we don't access on a daily basis in our attics or our basements. And that's actually the worst place for our family heirlooms, because basement tends to be cool. It also tends to be very damp and high humidity. And then up on our attic, it's high temperatures and also sort of follows whatever is happening outside. So the best thing you can do is to not put it in your basement or your attic. The next thing I would say to do is to employ that isolation method. And so if you notice that you are having an active infestation, like you can see live bugs on there, active frass, which I guess I should make sure that people know what frass is. It is basically just insect excrement, but it's called frass. And so if you're noticing that on your collections, you should definitely isolate them. You don't need to use fancy bags. You can get your Ziploc bags from the grocery store, and just make sure that you're keeping it separate from everything else until you can talk to a professional and see what you want to do with it.
Great. Another question that came in: what is the ideal climate, temperature, and humidity to prevent damage to a school library collection, specifically like mold prevention?
Yeah, so mold likes to creep up when you get really close to 70% humidity. We ideally like to be around 50% or even lower for certain materials. And so you really want to make sure that you stay I would say well below 60%. Because like I said, 70% is really that tipping point where mold can really just sort of take off and cause issues within your collections.
And what temperature would you suggest to go along with that humidity?
Temperature for like general collections, we really like to stick around 60 degrees. Again, depending on the material, there are more ideal temperatures for long-term preservation, but anything around 60 degrees is great. Humidity is really the issue that you want to make sure you have under control, though.
Awesome. How have the archive's mitigation methods changed over time?
So I think how we document and how we track things have changed. A lot of the traps have been around for a pretty long time, which I don't know what that says. Maybe they're effective and there doesn't need to be a change in them. But the traps themselves really haven't changed over time. But I think that the way that we launch them, how interactive we are with identifying our pests and tracking trends and really trying to calculate where our risks are, so that we can prevent things from happening. I think that that is like a fairly recent development, that we just have more data to use to prevent things from happening within our collections.
And have we been using that data to change any of the methods or ways that we're preventing additional pests?
Well, we haven't really changed like the type of pest traps that we use. We commonly use the blunder traps, but as far as like treatment methods go, I mean, we typically use freezing, but like I said, there have been instances where we've requested to use the CO2 bubble within the Smithsonian if you have larger issues. And so, yeah, I don't think that things have changed too much, but like I said, how we're using the data has changed and has made it a lot easier for us to anticipate future issues. And if an area is identified as an issue, we check it more often. Like if we have carpet beetles in the reading room, or we notice that there is silverfish in a particular collection, either we move it and immediately freeze it. If we're not seeing any live pests, we just sort of monitor it closely. Maybe we launch a trap right next to that collection, one of the blunder traps, so that if anything sort of migrates off of the collections, it goes right into the trap.
Another question came in. You mentioned that you can reach out to entomologists to help identify the pests. How does that work at the Smithsonian? We find a bug and then what? Like, what do we tell our entomologists? Do we take a picture? Do we walk over to natural history with the bugs?
So we have a really great relationship with our entomologists that are part of our Smithsonian Garden staff. So we work really closely with one entomologist in particular, and she will actually come over and help us do some of our inspections. And I know that she does that in a lot of our library spaces as well. And so, yes, really, if we're having an issue, I can just send an email to her because I have her email. And so take a picture with my phone and say, hey, I don't know what this thing is. Can you help me out with this? Or if we notice that we're having an infestation issue, we can call on her pretty easily to ask for treatment options or what her thoughts are on that. So we also have entomologists on staff over natural history, obviously, that we can also call upon. So yes, we are very fortunate at the Smithsonian to have lots of different spots where we can go to ask our entomologist friends.
Oh, this is a good one. Whose responsibility is integrated pest management at the archives? What department do you, as preservation coordinator, fall under, and how big is the team working on this?
Yeah, so I'm going to give like the textbook answer of it's everybody's responsibility at the archives, because really it is. Now, running the actual program and launching the traps and monitoring them and coming up with treatment options, that all falls under the preservation team, which is pretty common within a cultural heritage organization. But like I said, when I was talking about that tracking spreadsheet, it's really important to have all that information accessible to all of your staff because you can't have eyes everywhere. And so if there are problematic areas, everybody on staff who accesses those areas should know about it. So it's an extra set of eyes to see if something's happening. So yes, everybody's responsibility, but really overseen by the preservation team. Oh, and our staff is now, since we're now the libraries and archives, we have 7 full-time people.
Has a researcher ever found pest damage while in the reading room that we hadn't found before that? They said it must be so hard to keep track of collections, especially those stored offsite.
So specifically in the reading room, I am not aware of any situation personally that has come up where somebody has discovered pest issues, but I am sure that it has happened. But I have not been the person to be contacted when that has come up. So yes, I feel like that has happened. As far as off-site facilities, things coming back, we do inspections somewhat regularly for things coming in and out. They're spot inspections. We don't look at every book or go through every folder as things come back and forth. Fortunately, a lot of our off-site locations have great environmental conditions, and so it's not typically a primary concern for us, but of course can always pop up. And then was there another part of that question that I'm forgetting?
Just no. Okay. Just if the researcher had ever found damage in the reading room.
I'm sure, but I don't have a specific situation that I can reference.
There was a comment in the chat that I'll read off and see if we have a comment on. It said lots of school libraries end up with mold, especially due to budget issues at the school. If you could please issue a publication at some point with the ideal climate, that would help us all, or run it in the school library journal, such as your response about keeping it at 50% or lower to prevent mold. Most schools cannot keep their school library at 60 degrees Fahrenheit, so charged data's ideal range of temperatures and humidity would help the school library community a lot. So it's definitely some, no pun intended, food for thought.
Yeah, so there are already lots of publications out there for like appropriate temperature and humidity given specific material types. The AIC, American Institute of Conservation, has standards, and we also have some target temperature and humidity specs on our website, the Smithsonian Institution Archives website. There is a PDF linked in our, I think it's our environment section under preservation, but we can certainly get that resource for folks. But yes, it is already in publications, just need to get them to you.
Yeah, we're always happy to help provide the necessary data to get people to the advocacy tools they need for their collections. So Allison, thank you so much. This was super interesting and informative, and also giving me the heebie-jeebies a little bit. So thank you for this. I hope everyone will join us next month for our next film screening, and have a great afternoon.
Thanks, everybody.